At first glance, I thought the McLaren launch car looked pretty vanilla. But as I looked a little bit closer, I saw there's quite a few little interesting details that we can discuss in this video. We'll work our way from the front to the back of the car, looking at the various flow structures and aerodynamic devices around the car, specifically some of the detail work. For those of you that are new to my channel, I worked for Mercedes as an aerodynamicist for the 2018, 19 and 20 Formula 1 seasons, and I now work as an aerodynamics consultant designing aerodynamic packages for different race cars and different classes all around the world. Now, McLaren released some renders that are quite detailed in addition to having a live stream of their launch. It should be noted that on the live stream, some of the detailing along the floor edge looked slightly different. Perhaps there were some covers or something on it, but unfortunately the images are of such poor quality that I have to rely pretty much exclusively on the renders. And I think there's still quite a few details we can make out from these renders. It should also be noted that the front strakes at the front of the tunnels are decidedly missing. Historically, McLaren has always removed diffuser strakes from its launch renders, so this shouldn't particularly surprise anyone. Let's waste no more time and get into the front to back analysis. Starting off with the front wing, you can see that they're running that same disconnected first element that every other team so far has run. And that solution is something that I'd be expecting to see as a pretty common feature across the grid. That's certainly the way it's evolving. It's just a very neat and clean way of supporting the nose, particularly through the center of the nose, and making sure that you've got nice clean junctions along here. Now, the real thing to note is the fact that the front wing center is much lower than the Aston Martin one is. We're going quite low here. It looks like we're approaching legality. And this is a very different approach where we're getting a slightly more center-loaded wing here. And you see as a result, they've been able to back off these outboard and mid portions a little bit more than the Aston Martin's been able to do. And that will enable them to get a little bit more downwash in this outer region here, which is a strategy that many cars ran in the most recent years on the last set of regulations. Now, while we're out at the tip of the wing, you'll notice that there's this little discontinuity between the main elements and the little tiplet. I won't read too much into this. I think it's actually just the render having an element misplaced, because the rules are pretty clear that anything in this region has to be continuous with no discontinuities. It has to be smooth. It has to be tangency continuous. So all that sort of stuff has to be fulfilled, and this geometry would not achieve that. So I think that's just a rendering artifact. If you have a look from the top, you can also see that the rear wheels are in slightly different positions left and right. And so it wouldn't surprise me if these were just a little bit off in the render. Now, looking out at the end plate, what you'll see is that the trailing edge here is actually pulling in a little bit that way, and then it comes a little bit like that. There's a tiny divot in the leading edge as well. You can see it just comes in that tiny bit in this section here, but it looks like the trailing edge is pulled in more than the leading edge is. And that tells me that the mid portion of this end plate is probably cranked with respect to the lower portion and the upper portion. Now, this will naturally generate a bit of span-wise flow along the end plate, so it will push air that way, and this will help assist with the downwash down the bottom, and it should also drive a little bit of upwash along here, which might cast the top edge vortex sort of up and out a little bit more, which I suspected Haas was trying to do with their slightly different end plate geometry before. The other thing this could do is it could extend the space available for the outer dive plane, so they could perhaps make the span of the dive plane a little bit longer, and therefore that would allow them to power up the dive plane a little bit. Looking at the detailing a little bit further inboard, you can see that similarly to the other teams, we're seeing the appearance of this delta wing shaped flap pivot vortex generator. Now, this is a similar geometry to the Aston one, and I'm starting to think that this is going to be a very standard feature up and down the grid that is allowing them to have a point where they can cast any vorticity they're building up further down the car and capture any sort of sidewash that's coming along the wing, turn it into a vortex. Now, instead of the Aston Martin, which had its generator sitting somewhere around here, we've moved substantially outboard to over here. Now, I'm not going to speculate precisely on how they're using this and what this positioning change has done for them, but I'm sure that most of the teams would be experimenting with the location of this particular device and will have picked a setup that works best with their downstream flow features. Another thing to note about the front wing is it's the first one that we've seen on a 2022 Challenger that comes substantially off the back of the legality box there. So we can go the whole way up to there if they want, like for example on the Aston Martin, but they've come substantially off it. This perhaps ties into my statements earlier about them getting the load through the lower ground proximity and potentially slightly more cranked center section, but there is another potential explanation. Some people may have noticed that in testing videos of the Aston Martin running around, the car is running very flat. Now this is not wholly unexpected because there's a lack of a step plane this year, which means that this outer section of the floor is actually the lowest part of the car, apart from, of course, the plank. When you combine this with a large height tunnel just inboard of it, what it means is that running a low ground clearance in this particular region along here is quite beneficial because you will, to some extent, get a bit of a skirting effect. Now, these are my assumptions based on this geometry and my past experience in aerodynamics and particularly touring cars, but what we might be seeing is that some teams may have still been able to make it work with a slightly higher rake concept. Now, of course, as you raise the rear end of the car up, the front wing pivots around the front axle, so the front wing goes down. And that's why we've previously seen cars on previous rule sets running with their front wings really low to the ground. So maybe we can see some teams run a little bit of rake that will power up the front wing a little bit more and therefore allow them to cut down on the plant form and still have the front load that they need on the front wing. Or a much simpler explanation of all this is that they're just having us on with this render and the rear wing actually comes much closer to filling the box, which when you look at the live stream, it kind of looks like that might be a bit closer to reality. Unfortunately, at this point, this is all speculation and it's impossible to really know what's going to happen. Now, the thing that really had a lot of people talking on this car prior to launch was the pull rod front suspension. Now, this is something that has been tried in relatively recent memory with Ferrari, although this time around the game's changed a little bit because we now have these much bigger diameter wheels, up to 18 inches, and this means there's a lot more room to effectively package a pull rod that has a little bit more angle on it, whereas with the Ferrari, they basically had to put all the angle on the control arm and have almost a horizontal pull rod. Now, I'm not really going to go into the mechanical aspects of the pull rod suspension. I think a number of other people have covered this, and if this is something you'd like me to cover in more detail, please request another video in the comments. But what I will talk about a little bit is the aero implications. Now, there's nothing to me that straight up suggests that going pull rod is going to be a complete game changer in this region. In terms of what they actually might be doing by going push rod, well, they could be downwashing a little bit with the push rod. There's not a huge amount of angle that they're allowed to put on these sections legally, but maybe if there's a bit of upwash coming off the front wing, having this push rod here could help with the downwash, and maybe they're trying to bias that inboard and low by going with a little bit more downwash here than out here where it's going to sit a bit higher. That's one potential use for it. The other thing they could be doing is they could be trying to clean up the lower portion of the caketin face. By removing where a push rod would normally go down here onto the caketin, they can get rid of any losses that might be coming down in this lower portion and the junction between the lower wishbone and the push rod, and they can clean up this particular area through here. So they may see some gains doing that. It's worth noting though that both the Haas and the Aston Martin run their push rods quite decoupled from their lower control arm and actually quite high up. And in the case of the Aston Martin, it's coming in through the scoop. So I wouldn't have thought there'd be a huge benefit in this particular decoupling. While we're here out at the front caketin, you'll notice that as per the Haas, the brake scoops are absolutely tiny. Now this potentially supports one of the theories I discussed in an article I did for MotorSport magazine, where I suggested that maybe the large scoop that we saw on the Aston Martin's caketin was to blow air basically through as a bypass through the scoop. Now there's a rule that they have to pass any brake ducts through a plane that's outboard of a certain location. So if they were to run any sort of bypass, they have to go pass it through and pass it back. And maybe that's what Aston is doing. I mean, it's impossible for me to know because I can't see their caketin, but maybe that's why they're using such a big scoop. The other thing they could be doing is just flowing a whole lot of air for rim cooling purposes. But in the McLaren case, they're clearly just trying to make the scoop as minimal as possible with as minimal an aerodynamic impact and as minimal a wake as they physically can. And it'll be really interesting to see what all the cars rock up with to test and race so we can see what path they're actually planning on taking in this region. Moving a bit further back, like I mentioned, the floor strakes are removed from these renders, but we can still talk about the outboard fence / barge board and the floor leading edge, both of which are fairly interesting. And what I've done here is I've overlaid my legality volumes over the top of the top view of their car, And there is a little bit of parallax because of how we're looking in terms of the perspective on their camera versus I just shot my render of my volumes from straight down. But what you can see is that the volume that you can put the outer strake in comes along out here and then notches back in. Now in the case of the Aston Martin, they obviously go the full way forward in this legality box with that mega jumbo outboard strake. But what the McLaren does instead is that it follows the outboard periphery of the floor and then it kinks in with a really steep strake. And I wouldn't be surprised if, given where this strake terminates, that it's either tucked up to the edge of this legality box or maybe even encroaching into this legality box. There is a little surface that they have to shadow through here so that it can't be visible from the outside, but it looks like they are more or less pushing the limits on where legality allows them to put that nose in terms of bringing it inboard. Now, what are they doing with this? Well, I'm going to guess that it's all about outwashing the wake. So like most of this area, we're all managing the wake control, and with this case, we're trying to build up a little bit of positive pressure here. So we're going to really force that wake outboards and gain a little bit of outwash. And that's why it's kinked in so heavily, because that's going to build that pressure that we want and direct the flow outwards. Now you'll note their particular design has meant that they can't have the tallest barge board bit in the world. But if you have a look at their Sidepod design, what you'll see is that it's really bluff with a really fat lower section. No undercut at all. It's just really massive. And this is going to build up a lot of pressure here. So I'd say what they're doing is they're going to use this lower section down here to manage out the lower wake. They can use the big pressurization budget from here to manage out the mid wake and push that out. And then obviously the top vein along here will manage some of the upper wake. But then anything that's left, the pod will sort of deal with its little bit of stagnation. And then if you have a look, the pod tucks in not the whole way out to legality. So if we do have some wake sort of coming in, it's not going to latch onto the pod. Now that stagnation in front of the side pod also feeds into the next point I'm going to make about their super sharp floor leading edge. You'll see that compared to the other designs that we've seen, we've got a very sharp edge that then curls down into the floor here. And then of course we have a fillet that mates it through to the bodywork. I won't speculate on the curl down, but I will speculate on the sharp edge. So we've got what I identified before, which is a high pressure region in front of this side pod, and that should force a decent amount of downwash onto the floor leading edge. And I'm thinking that there must be a fair amount of downwash, because if you actually look at the profile through here, what it kind of looks like from the side is that it's got a relatively flat top, quite a sharp bit, and then it curls around something like that. Now the alignment on this being such a sharp edge instead of something like the Aston Martin, which would be more of a really bluff edge like that, means that the red profile that the McLaren uses is not quite as tolerant to flow misalignment. So if we have a lot of flow going either up or too far down, we don't have a huge amount of acceptance angle. So flow going up could cause some separations off here. If we're too sharp, we could get some peaky pressure along here and some extra losses as we go further downstream. I'm sure they've spent plenty of time analyzing this and making sure that it works in all sorts of different car conditions, but it's just worth noting that this particular setup would be more tricky to align than the big bluff edge. And it probably does indicate from the geometry that they are getting a decent amount of downwash from the side pod. Whereas the Aston Martin obviously had a giant hole through here and a downwashing winglet, so they have to run a very tolerant front edge. Now they could be doing something tricky with their strakes in here as well. Having not seen the strakes, we can't really know anything about it. But as a general rule of thumb, thinning out this area should theoretically cause a little bit of a local drag, say, from less of a bluff body at the front here. You'll then note that along the center line, they're running a fairly standard T-tray style setup or bib setup that is more in line with what I pictured the rules were going to prescribe compared to, say, the Aston Martin setup with its double T-tray. However, it's worth noting that they actually are very thick in their sectional depth. So compared to a normal setup where you normally have quite a flat sort of T-tray so you can get a sharp shedding edge and get your vortices coming off the bottom of it, they've really thickened that up. I wonder if maybe that's a little bit of an effort to cast the vortices that are shed off here a little bit further inboard and under their central floor section. Hard to know for sure, but generally speaking, when you look at the front view of something, if you have an edge like that with some downwash on it, you'll cast a vortex kind of here-ish. If you have an edge like that with some downwash on it, you're probably more likely to get your vortex down here. But I guess by that argument, they probably could have made the T-tray a little bit narrower as well. So not 100% sure what they're doing in this center section. It's also worth noting that where that sharp edge of the floor runs down, it almost looks like it's separated off the body of the T-tray. It's impossible to tell from the particular shots whether this is definitely correct. We'd have to have a look at some shots in real life, but there's definitely something unusual going on there. Just a quick look at some cockpit detailing now. You can see that they've got these two little vanes, one on either side of the cockpit there. My guess with those is that what they're doing is that they're going to spool up a vortex along them that's going to spin that way as they go along here, inwash some of that air down the bottom of the vortex, and hopefully suppress some of the cockpit losses and the lossy air from the cockpit from escaping out. Of course, it will have the problem if there's any higher up losses that it will drag them up and out. They've then got some wavy mirror stalks with no stays compared to all the other cars which do have stays. Not going to speculate too much on what they're doing with these. Moving a little further rearwards, you can see that they're running a fairly conventional curl here. It's a little bit softer than what we've seen on other cars, a little bit more blended, but it is worth noting that it did appear, although very hard to see in the launch live stream, that there is perhaps a little bit more going on here with respect to maybe they've stepped this particular portion of the curl up a little bit more, have a bit more of a gurney on it, or have otherwise made it more aggressive. Quite tricky to see what was going on, but it didn't look like the renders. Further rearwards, it appears that in the launch live stream that they also were having either some sort of weird notch or curl geometry going on here, or otherwise they've got some sort of cover over the bodywork so you can't see what's going on. Either way, I'm not sure what they're doing here, but I'd hazard a guess it's not going to be like it is in this render. Looking at the back of the diffuser, there's actually a few interesting things going on in this rearwards region here, just in front of the tire. The first is that there's a very progressive ramp up from the edge of the floor, ramping up into this section, and then they've got a notch that's coming down. Not dissimilar to the Aston setup, but a little bit more subtle. The Aston setup also was flat along here and then sort of curled fairly sharply up and then ramped up to the notch and then cut back down. Whereas the McLaren setup is generally just softer all over. You can see it better from this angle, how it ramps up into this cut notch and then it works its way down along there. While between diffuser, let's talk a little bit about the kick line. It seems that McLaren is running a double kick setup similar to what we've been seeing on cars like the Aston. We've got a flat tunnel along in this portion here, and then we've got our first kick, and then it goes down, kinks at what I assume is legality because it's a very crinkly surface on the top, so I assume they're running as tight as they can to legality, and then it kicks back up. Now it's worth noting that this is a much more subtle double kick than we've seen on the Aston Martin, so they've definitely gone for a little bit less of a suction peak further forwards. It's a little bit less aggressive of a strategy. Perhaps here they're trading off a slightly cleaner system with a bit less loss for a little bit of overall suction further forwards. Now for a final bit, let's just have a quick discussion on the cooling architecture. What I've done here is I've overlaid the previous year's car onto this year's car. You can see it's a little bit longer out the back because these rules on the new cars stop you from having as long a wheelbase as previous years. But basically what you can do here is you can see the differences in the bodywork, and fundamentally a lot of the bodywork strategy is still the same. We obviously have a further forwards inlet here, and the side pod's that little bit fatter. Obviously because we're using it for weight control, it's an interesting shot too, because you can see that the leading edge of the side pod is actually pretty comparable to the barge board kick outline, so that's quite an interesting one to look at. But then as we move further downstream in this sort of coke section from here to here, we're still following more or less the same coke strategy that we were in the previous years. Obviously we're truncated a little bit at the back, but generally speaking, the strategy is not that dissimilar. They haven't gone for anything radically different. And of course, if you look at the back, we have this taper in and undercut, and it's very likely that this exit is exiting a little bit higher than the old one, and there's probably a little bit more taper in at the bottom. Again though, we're not talking radical changes here. We're just talking optimizations in terms of getting a little bit more clean mass flow in underneath and getting it through to the rear elements of the beam wing and the outboard of the diffuser, much like the philosophies that all the other teams are following here. So that is all pretty straightforward to me. And just another note on cleanliness and rear airflow is that they've gone to a pushrod suspension for this year at the back, and that to me is a decision that kind of makes sense. We've got a bit more of diffuser height than we have in previous years, particularly around this point. We're trying to really maximize the cleanliness of the flow to the beam wing and the rear. All the teams seem to be pushing pretty hard to do this. By going to push rod, we can help gain a little bit of clearance at the inboard side, get that rod a little bit more out of the way, and therefore we can maximize the cleanliness of the airflow lower down. Only time will tell, though, whether or not the push and pull rod is the right bet to go for, because they're pretty big architectural choices, and it'll be interesting to see if any other teams have followed suit. Well, that's all for this analysis video. Thanks for watching. If you enjoyed this video, don't forget to hit that like button and subscribe to my channel for more content like this. I'm doing a whole series on every car as the launches come out, so stay tuned for more there. Thanks for watching, and hopefully, I'll see you next time.